Hello everyone, today we are going to talk about heat conduction within a wire. In this example, we are talking about a conductive or resistive wire that is placed in water in order to boil it. So first to start, we need to start with the heat conduction equation. That is given by rho Cp del T over del T is equal to gradient K gradient T plus Q triple prime. This equation can be simplified because we are in steady state with a constant K and we're working in cylindrical coordinates. This equation then simplifies down to 1 over del R times R dt over del R plus Q triple prime over K. The boundary conditions are there are two boundary conditions, I should say. They are convection and an insulated boundary. With the insulated boundary, it is del T over del R evaluated at R naught and T. For convection, it is negative K del T over del T, which is evaluated at R is equal to R naught, is equal to H times Ts minus T infinity. The temperature distribution shown here with the equation, the temperature distribution is shown by the equation T is equal to Ts plus Q triple prime R naught squared over 4K minus Q triple prime R squared over 4K. This equation is shown in the bottom right graph. The second R in this equation is what changes as you move in and outside of the wire. So the radius shown here is in meters, that the further away you get from the inside of the wire, the temperature drops with the same rate as a quadratic. The center temperature is at 125.1 degrees Celsius. These three graphs show how different parameters change the temperature distribution. The change in radius overall will result in higher temperatures, but it has the same temperature gradient, or same temperature distribution, I should say, throughout the wire. The equations will vary slightly, but they are fairly close to each other. The heat generation and thermal conductivity, on the other hand, will not make a difference because they both of these graphs will converge to the same point. So no matter how you change the heat generation within the wire or the thermal conductivity, they both converge to the same point, meaning that they will have no noticeable change on the boiling of the water, although they will result in higher or lower internal temperatures of the wire depending on how you change it. If you were to quadruple the heat generation, the internal temperature of the wire will increase, but the outer temperature of the wire will stay the same. The inverse is true for the thermal conductivity, that the lower the thermal conductivity, the higher the temperatures, but again, they will converge to the same point. Lastly, how would I redesign this? So I would redesign this wire by maximizing its radius. The greater the radius, the greater the overall temperatures throughout the wire, as well as the exterior of the wire. But changing the heat generation or the thermal conductivity does not matter, so those do not need to be adjusted at all. In this presentation, I have shown you an example of how to use the thermal conductivity equation, and I have shown you the parameters, how they change with a wire in boiling water with the radius. I showed the change in the radius, the thermal conductivity, and the heat generation within the wire. Thank you for listening.